It's just very low. All right. So here's the second half of the evening. That was a fantastic visit from Clay. I appreciate the fact that he came over. I hope you do too. But we're going to take a shift now to the era of commercial. And I think this is going to be a fascinating session. It's going to be chaired by Dennis Stone, who is the Assistant Manager for Commercial Space Development in NASA's Commercial Crew and Cargo Program at JSC. He has been the chair of the business committee for both of the COTS competitions, and that stands for Commercial Orbital Transportation Services. I always mess that up. I want to say off the shelf. Commercial Orbital Transportation Services. Yeah. He spent 20 years in NASA working on the space station program in a variety of positions, including Chief Systems Engineer of the Assured Crew Return Vehicle, Manager of the Avionics Integration, and Co-Chair of the ISS Commercialization Working Group. Prior to working for NASA, he's worked for McDonnell Douglas, Ford Aerospace, and Rockwell. He has a bachelor's degree in physics and in electrical engineering from the University of Hawaii, an associate fellow of the AIAA, and advocate of the Space Frontier Foundation. Please welcome Dennis Stone.
Thank you, Jim, and thanks everybody for coming out on the weekend to show your support for space. And tonight you're interested in commercial space. This is something that I've been interested in for a long time, shall we say, and I'm so proud and honored to be part of really a new and exciting effort by NASA to stimulate the commercial space sector. And we're doing this in several ways. We started about 5 years ago with COTS and the Commercial Orbital Transportation Services. And this is the two-phase program. The first phase, NASA is an investor. We had $500 million, and we were invested in two companies, SpaceX and Orbital Sciences, that are developing the ability to fly cargo to, and in some cases back from the space station. And this first phase is one of development and demonstration. The second phase is a contract from the ISS program, the Commercial Resupply Services Contract, or CRS, and that's a multi-billion-dollar contract. So we're putting our money where our mouth is, and we're really trying to get the commercial space sector routinely carrying cargo to and from low Earth orbit. We're also beginning to make small steps toward the next logical step, which is to allow commercial industry to carry people, beginning with our astronauts up and down to low Earth orbit. CCDEV is a commercial crew development program. We're just finishing up right now with a $50 million investment in activities of 5 companies along those lines, and proposals are in for CCDEV 2 right now, next step. And we'll see what the budget says next week about the full commercial crew program, but last year the President had proposed a nearly $6 billion commercial crew program. So we're really excited about this new exciting program to really develop commercialization of low Earth orbit and help free NASA up to go back and do the Lewis and Clark stuff that we do so well. And we have a great panel of 6 companies here today. Rather than read your bios, which I don't even have, I'm going to let you introduce yourselves as you begin. So we're going to start with John Curry of Sierra Nevada.
I think it should be hot now.
Can everybody hear me on this? Okay. So I'll let you do the charts. We'll start with the charts. I think most of you here at the Johnson Space Center in the Clear Lake area might know me, but my name's John Curry. I worked at JSC right down the street here for the last 23 years. First as a flight controller, and then I was a flight director for about 10 years on the shuttle and the space station. And then my last shuttle flight was STS-116, a 12-1 mission. That ended in December of 2006, and then in January of 2007, Jeff Hanley gave me a call and asked me to go work on Orion, which I did work on the Orion project as a vehicle integration manager. I've got a lot of blood, sweat, and tears on that space vehicle, So look forward to eventually seeing it fly, and I want to make sure that that's one of the things that you get is that you know, space flight is important no matter what particular vehicle you're talking about, and that's a good vehicle. I spent a lot of time on it. So I did that from 2007 until 2009, and then got promotion up to Constellation Design Integration Manager, and that was going really well up until February 1st, and then things changed a little bit. You guys are laughing, so you know what happened after that. And so after that point, after working on that for another few months, I went ahead and took a job with Jim Voss and Mark Sarangelo and working on Sierra Nevada Corporation. So that's what I'm going to talk to you about, is what we have been doing at Sierra Nevada with respect to commercial space and the space vehicle that we have. So next chart. Let's see, these are just the questions I think that Cindy asked us to say something about, so hopefully I'll cover these at some level where it says the progress made over the past year. We didn't do anything with COTS. That was, like he said, that was Orbital and SpaceX, so I'm going to concentrate on the CCDev-1 progress, and then I'll briefly touch on the other two things. I think I've got 10 minutes, so I need to go fast. Next chart. A lot of people don't know much about Sierra Nevada. I didn't know much about Sierra Nevada when I first started. It is not the beer company, although I wish it probably was. Always say that, and I get that. I get asked that question all the time, so I keep telling Mark we just need to buy them so that we can actually have the beer keg with us. Sierra Nevada, actually, as a company, has been around for a long time. And I'm not going to spend a lot of time on this, but they did a lot of work. They still do very good work in defense side of things. And so there's 7 groups here that you see on these charts that have been around. The 6 to the left have been around for a long period of time. The one on the right is the one I'm going to concentrate on, which is the Space Systems Group. That was formed in 2008. And so the company was doing so well that they wanted to venture out a little bit more into the space sector. And so, but there's a lot of good work over here on this company that's been around for a very long time. I'd spend more time on it if we had more time, but so on the Space Systems Group part, in 2008, Sierra Nevada acquired 3 different companies: Microsat Systems, StarSys, and then SpaceDev, which y'all have heard something about from the previous time. And so that now comprises Sierra Nevada Corporation. So it's a pretty big company, over $1.2 billion in orders last year. So not a small company, been doing this for a long time. Have components and parts and pieces on over 300 space missions, and some of the stuff is shown on here. Next chart. So on Space Systems Group, again, we've got basically 4 product lines. Spacecraft systems type stuff, which is shown up here, including things like the Orbcomm Gen 2 satellite, which is a more of an assembly line type contract where they've building a number of satellites to put into space. And I think SpaceX is launching one of those on a Falcon 9 here soon. And so that's a multi-satellite service that actually, like tracking packages and those kind of things, what those satellites do. Subsystems and components, there's a lot of components that we have put together. Very proud of that record that they've been doing, and that's in Louisville area where I commute to every single week. All of these things are with this one. Space Exploration Systems is the area I work on. I'll concentrate on Dream Chaser here in a minute. And then on the prop systems, most of you guys probably are aware or have heard, if you're sitting here listening about commercial space, Burt Rutan was able to successfully do the Spaceship One flight, and that was the motor that was used to get Spaceship One up was built by SpaceDev, which is now Sierra Nevada. So next chart. So this is just the chart summarizing all the capabilities and things that we've done. The 4,000 components. Mark Sarangelo, when he briefs this, always very proud of the fact that we've had over 4,000 components on 300 space missions, and not a one of them has broken yet. For example, Spirit and Opportunity that are on the surface of the moon, all the moving parts on those things are there. Next chart. So on the Space Systems locations, this is where some of the parts are built, like the environmental control and life support part. I mentioned Orion earlier, for example. Some of the parts that Hamilton, and this is their sub to Hamilton, it comes out of that area there. The Poway, California plant is where the rocket motors are built, and then the test facility for the rocket motors is also in California, not that far off. And then Houston, we're just now starting to set that up. I am the guy that's going to be starting to set up the Houston office of that. And the main focus of where we're doing all of the component work and actually going to be putting the Dream Chaser together, including the one that we're working on now is out of Louisville, Colorado, which is just south of Boulder, if you guys never. Beautiful place when it's not minus 20. So this is a picture of the Dream Chaser. It's a winged vehicle that, so now I'm going to focus specifically on the space exploration systems. It's a winged vehicle. This is shown docking to Node 2 forward, which is one of the 2 ports that NASA's been working on us for. I'm working on the integrated system thing. That's why Jim handed this job to me to make sure that that'll work. Got a lot of experience with space station. The scale, if you compare this to the space shuttle, distance from nose to tail is about 30 feet, and from tip to tip on the airfoil wings, it's about 27 feet. Just to give you an idea of the size. 7 people inside the cabin, two pilots, and then 5 passengers. Next chart. A lot of people don't realize that the shape that I was just showing you flew in orbit. The Russians did it on a spiral, what they called the spiral program back in the late 70s and early 80s. What they called the Bor 4. Sox may remember. I don't remember what the acronym is, what BOR stands for, but it's some Russian acronym that basically means being able to do these orbital missions and reentry. And they did that all prior to the Buran program, got a lot of TPS knowledge on the fact that that system would work. And the picture's not shown here, but an Australian P3 apparently saw the thing being pulled out of the water. They took the photos, sent it up to Langley or wherever, and then somebody asked Langley, CIA or whoever, to reverse engineer the thing, and that turned into what we call the HL-20. So the HL-20 has got over 2,000 wind tunnels, 2,000 wind tunnel tests that were performed during that period of time, and for a brief period of time, if you look at history, the HL-20 was going to be the manned space, next generation manned spacecraft, and then things changed a little bit, and Dan Golden came in, and things got overcome by events, and we ended up with the X-38 that was managed out of JSC. But it was nothing to do with the design. It had to do with just what NASA thought was the that they wanted to go with, and so we went out of the JSC design. Chart. So that's the Dream Chaser heritage. It's got a lot of good heritage from the NASA HL-20. I already mentioned that it's 7 crew capable. One of the things, just like Keith and I were talking, 2 minutes, so I need to go faster. This is the capability of the vehicle. It launches on top of an Atlas V. Jeff will talk about that, so next chart. We've been working on this for quite a while. Next chart. So the accomplishments, hey, 2 minutes, I can make it happen. So these are the 4 milestones that we did during CCDev-1. There's a lot of good stuff. It's very hardware production centric. I like that. It's one of the things I like this, you can show tangible progress when you cannot dispute hardware. So that's what we did. We built the tools to make this, and so this is turning in what we call the engineering test article, and that is going to be the vehicle that we're planning to drop from 45,000 feet next year. So, and go back one more real quick. We also did a hybrid, what we were talking about, what we call the hybrid motors that are used on the back of the Dream Chaser. That's a rubber, green propellant, rubber and nitrous oxide is the way that's done, just like on Spaceship One. What we did different from what Spaceship One does, we had to prove that it works in a vacuum, because Spaceship One was doing it in the air. We did multi-start capability to show that you could do it for rendezvous and deorbit. Next chart. This is the other stuff that we did, a lot of GNC work. Next chart. A lot of other work. I'm not giving it due credit on what we were able to accomplish. Next chart. And then I think if I've got 1 minute, the last thing I'd like to show is we partnered with the University of Colorado Boulder. Some grad students did built a 1/6 scale model of this thing, and can we cue up the video? And it's less than a minute. But University of Colorado Boulder did this with us. The students built this vehicle. Sorry for the noise. So this is showing, I don't know if you can hear me, but this is what the students doing the work on this.
A scale model of the Dream Chaser was created. The model was subjected to both functional and flight tests.
5 seconds.
So this was December 9th.
Good drop. Confirm release. Ground station first vehicle is flying.
And this, remember, there's nothing wrong with the design of the vehicle that's causing oscillation. It's just because because of the
Vehicle
way
with
that the vehicle
128
is
knots performing
built,
nominally.
it's not that, it's not.
Ground station confirmed chute deployment. Can I have a visual? Copy, good shoot. And ground station confirms touchdown. Thank you.
And that was Mary Sanchez talking there, who also came from JSC. So anyway, that's the kind of things that I like about working in this commercial stuff, and each one of these other folks is going to give you a chance to do that, but we did that with a very small amount of money with the University of Colorado, and I thought the students did all that. I thought they did a very good job, all things being equal. Do I need to give up my time now that it's time? I think I'm the last chart or two. I think we were just down to the last chart or two. This is all the folks we're partnered with. Next chart. So there were some questions about what we'd want to do, and I think everybody, I won't necessarily go through this, but this was one of the questions about how we can all work together, and you know, all of us, everybody has a common goal. The reason you guys are sitting in this room, and hopefully some people watching on the TV, is everybody believes that this shouldn't be it. You know, the space shuttle is a wonderful machine, and we're about to lose a huge capability, and that's why all of us believe in this. We're all bonded together to put this thing together. And I mentioned Orion. A key thing on that last bullet there, the ISS crew transportation and beyond LEO exploration are two totally different things. Orion should go. And LEO we've been doing for a long time. Commercial, now the time has come. I wouldn't be working here, and I think these folks who are about to talk would agree with me. Next chart. The last chart. So one quick thing about what we're going to be doing with JSC. Obviously, there's a lot of us that worked here. My boss is Jim Voss, who you guys may or may not know, but he's an astronaut who flew just like Brian and Sox. Great guy to work for. Mary Sanchez was the X-38 deputy program manager. I did a lot of stuff. So I know a lot about JSC capabilities. I know a lot about Clear Lake, and that's why we're setting up a Houston office. We are working on a Space Act agreement right now with JSC. Do some JSC work for us, and we're going to keep doing that and setting that up. Okay, that's all I had.
Thanks, John. Sorry to make you dance there near the end, but you did well. Next up, Keith Riley of Boeing.
I'll try to go. Can you hear me here? Okay. I'll try to go pretty quick. Some stuff. Can I have your charts? I hadn't seen some of that stuff.
He's kidding.
No, we are competing, so everybody understand that the guys here are competing against each other. So it's sort of a little dynamic. We're having some fun. My name is Keith Riley. As far as history, you know, I worked in the space industry for 30 years. I was a satellite controller, space mission controller. I was the Russian integration manager for the space station, the mission integration. Then I went off and worked commercial satellites for about 5 years, which was a very interesting place to go work after being in the NASA world for a long time. Went back and worked in CEV for the Boeing Northrop Grumman team. Then we lost, of course, so we quit doing that. And since then, I've worked Altair in a number of different commercial kind of activities. So I'll tell you a little bit about what Boeing's been doing for the past year or so on commercial. CS100, there's a story behind how we came up with that. I guess I'll share it here. Everybody goes, that's a little technical. What happened was we asked to put together a video on a very short notice for the president. So we had like 3 days to come up with a name. We called Chicago, and that's what they gave. So here we are. I'll probably get in trouble for admitting that. So next chart. So what are we doing? I'll talk about the concept. A lot different than what John just showed. It's not a wing vehicle. It's a capsule. It's very similar to Apollo. And I'll tell you, there's goods and bads for vehicles and capsules. And there's a lot of debates. You can talk to anybody. And you can argue either side. I'm quite capable of arguing either side. And I will say that the reason that we went with a capsule versus a wing vehicle is just it was simpler and it would be quicker. But there's a lot of advantages to a wing vehicle. I don't want to say bad about them. So what we're trying to do, we're trying to be safe, very reliable, keep it low cost, low development risk. We really believe that the fact that NASA doesn't have the capability, or won't, when shuttles shut down, the capability to put humans into space is a very bad thing. We really believe at the Boeing Company that gap should be as small as possible. So we really picked a design that we thought we could do as quickly as we possibly could do. One of the things that's unique about this vehicle is we designed it to be compatible with a range of launch vehicles. I will apologize to our ATK friends. We actually are looking at ATK as also a possible launch vehicle. I just didn't have it on this picture. My apologies. But you can see here, there's a Dragon, a Delta, and an Atlas. Just make sure I get those right. Oh, sorry, Falcon 9. You're right. Hey, I saw it. It was in D.C. a couple days ago. It was really neat. Yeah. Let's see. Operational 2015. I'll show you a schedule here in a second. And this is a key system. So we're doing the spacecraft. We're basically procuring the launch vehicle and integrating with the spacecraft. Ground operation, ops, recovery. Let's go to the next chart. So this is sort of, nothing surprising here. The launch vehicle, probably out of Florida, no doubt. And we can go either to a space station or the Bigelow Aerospace Station, or Bigelow Space Complex is what they call it. We've been working with Bigelow for some time, in interfaces, as well as Bigelow supporting us on the contract, and I'll show you some of that later. So we're really trying to branch out for other customers on the space station. And as you see, some of the things that Boeing's done publicly, we talked to Adventures. We're looking at other potential platforms we might visit. Once it comes back, it lands with parachutes, very Apollo-like, but the difference is it lands on land, which I'll talk about a little bit later, I think. And then we reuse the capsule, we put a new service on it, we do it again. So that's pretty much the cycle. So what did we do the last year? We started a year and a half ago with that very crude thing looking over there in the corner, and we took it to a systems design review, which is the design we have here. And I guess I don't have a lot of charts on what the design concept is. I'll say a few things here to give you an idea. There's one crew. It's got a capability of staying on orbit for about 48 hours. We decided to go with a battery system versus solar because it was simpler, quite frankly. And as we went through and did our mission timelines, we realized that was definitely adequate for what we're trying to do. We're simply going up to a platform, and we're on the platform, we're taking power from that platform, and then for 210 days. Here is where we did the hot fire about 8 days ago out in the lobby. That was really interesting. We were 400 feet away from that thing, and it's about a 60,000-pound engine. And that's the right way to say it. It felt like an earthquake. The earth definitely moved when they fired that. The fire was about 3.5 seconds. Here we have our avionics facility, and this is, folks asked about what we're doing at JSC. We actually did this testing at JSC at the ArcJet test, and that was for our heat shield material. Next chart. Some of the things we did at Big Aerospace, they built that mock-up for us. We called it a boilerplate. And since we're landing on land, we have to have some kind of deceleration system when you hit. We're using airbags. They're actually the airbags that Orion had. And we basically adopted Orion them for weight, I believe. John may say. Yeah. But we're not as weight constrained as they are. Same reason. They have to go all the way to the moon or Mars. We don't.
It was the weight to Mars.
Right. That was really driving them. So it allowed us to go back and look at that, and they're actually the exact same airbags that Orion was going to use. And we tested those out at Big Aerospace. One of the other things that Apollo had to deal with was when you land in the ocean, and this would only be in an emergency, you can actually land upside down. You can flip upside down, and then it'd be a little hard for the crew to get out. Okay. And so we have some we call uprighting bags, and you fill those up, and then it flips back up. Let's see, next chart. This is some of the mock-ups we did. You can see them. In fact, it's here in Houston at HBSC. Anybody wants to see that, just give me a call. We'll go show it to you. This is some of our Bigelow guys. This is actually Tommy Londergan. But I thought, he's really got the Story Musgrave thing going, so we thought we'd use that picture. Tommy will kill me when he sees that. Next chart. Why can we do this as quickly as we can? Everybody thinks about Boeing being a very large, lethargic company. And really, the things that we've done is we've adapted a lot of systems that we either already had or that other folks already had that we could use. We're taking the APAS docking system, although we are talking to NASA about the common docking system, which is very similar. Our AR&D system, which is how you dock to the space station, is from an Orbital Express program that successfully worked about 2 years ago in orbit. So we're not inventing anything there. The parachute system is exactly like Apollo. So it's Heritage Apollo, and it's also leveraged off Orion's work. Let's see what we got there. BLA is a proprietary system that Boeing uses on other programs, so we've used it before. That's the base heat shield ablative system. And then the structures are based off the Delta program, where we've been doing those kind of spin-form structured for a year. And then I already mentioned the airbag. Next chart. So let's see, what's this chart say? So we've made a lot of progress. Yeah, right. We completed our system definition review in October. It's a low-cost system. It's very simple. We're using existing technologies. We're going to go on proven launch vehicles. We're talking to all the launch vehicle providers as we speak. I think, you ask about some of the barriers. Where's Cindy? One of the barriers, of course, is that the way this is set up is it's a fixed price development program, which is a big, big risk for anybody. Because as everybody knows, when you're trying to develop something new, there's a lot of things you don't understand, and so your costs can grow. So the biggest risk to us is, are we going to sign up to a fixed price contract for development? And so, but I think in the end, we've worked it up through our chain, and I think we're ready to go forward. We're hoping in the next few weeks, so we'll hear something from NASA as far as going forward with CCDEV 2. So that's all I got.
And officially, no comment. Thanks. And next, from one of our COTS partners is Orbital, Jeff Siders.
I thought we were going down the row here. So, I'm Jeff Siders. Real brief background. I've been in JSC area since 1982. Started at MacDac and followed the shuttle program through most of my career in the flight design, flight dynamics, mission control areas. And then as the contract went from MacDac to Rockwell and USA, and then just recently went over to Orbital Sciences. So what I want to do today is just give you a little background on what Orbital's been doing. As Dennis mentioned, we've got COTS work. Go ahead and go to the next slide. So I'll give a little background on what Orbital is all about, what we're doing on COTS, and then what we've put in for the commercial crew activity as well. Next slide. So a little bit about Orbital. It's been around since 1982, primarily in the field of satellites. It picked up the Delta II class type satellite work, and also launch vehicles. We have a facility down in Chandler, Arizona that does all our launch vehicle design. And I'll show you in a minute in the Dulles facility where we build a lot of satellites. So that's been Orbital's core business. You can see we're at 3,600 employees, a lot of backlog, a lot of work, and so far things are going good. So next slide. These are our facilities. Dulles is where our headquarters is located, right outside Washington. Chandler, as I mentioned, is our launch vehicle development. We just acquired the satellite facilities in Gilbert, Arizona, to kind of help keep up with our satellite building demand. And then we've got our technical folks, services folks in Greenbelt, Maryland. Next slide. So this is our kind of overview of a satellite history since the early days. Orbital's been involved in a lot of foreign, national, DoD, NASA type satellite work over a number of years. Next slide. We're trying to build on that as we go forward. You can see there, Pegasus is where we kind of started our niche. And building off of that into Taurus, which we'll talk more, has been evolved to our Taurus II vehicle, which we're using now in our COTS missions. Next slide. So a little bit about COTS and CRS. Slide. This is our vehicle we're designing right now. It's called Cygnus. I'll tell you a little bit more about the details of it. It's a cargo resupply, carry roughly 2,000 kilograms to station. Next slide. So we started in February 2008. We've got one demonstration mission, hopefully going to fly later this year. We're shooting for the December timeframe. We've got 8 of the commercial resupply flights that'll occur between 2011 to 2015. What else? And we're making progress in all those areas, which I got another slide on I'll show you. Oh, go ahead, next slide. So this is the components of our COTS system. Over there on the far left is our Cygnus vehicle. We involve cargo operations, mission operations, and our launch site operations with our Taurus II vehicle. We need to get this all to come together. Next slide. So the Cygnus vehicle itself, primarily have 2 components. We've got a service module there in the back end, which houses all the nav sensors, propellant systems, and whatnot. The front part here is your pressurized cargo module being built by Alenia, who built the MPLMs for shuttle, and a pressurized cargo capability. Next slide. A little bit more about the PCM. We're using, as I mentioned, kind of the MPLM design. A smaller hatch than what they're used to on the station, but I feel that fits all the NASA's needs of transferring cargo. Next slide. So what we're involved with is, as I mentioned, 2,000 kilograms of cargo. Any kind of transfer bags that NASA wants to bring up, or even mid-deck payloads, mid-deck lockers. Next slide. Of course, we also have to deal with the trash, so our vehicles also will be stuffed with the trash and then burn up on re-entry. And this is our picture of our Carl Walls, who's now with Orbital doing all our mission ops and cargo ops work for the program. Next slide. This is where we'll be docked on station, Node 2 Nader. Will be grappled by the arm and then berthed to that port. Next slide. So where we are in some of the development, we've got a few of our hardware coming together now, as I mentioned, toward the launch later this year. So we've got our PCM modules being built in Italy. We've had some cargo demos with the crew. Next slide. On the service module, it's being built in Dulles, and that's all the harnesses are being put in. All the other structural elements are coming together. On the launch vehicle side, next slide. This is our Taurus II vehicle. It's being built for a variety of missions. It can be launched out of Vandenberg or other places. For the COTS and CRS missions, we're going to use Wallops as our launch site. So we're working with a lot of those folks to get a new launch infrastructure built to launch this rocket. Next slide. A little more detail about the rocket, 2-stage. We've got an ATK upper stage. Brian will talk about. Aerojet's building our 2 HA-26 engines on the first stage. Next slide. So we've had a first delivery of the first stage from Yusnoye in the Ukraine. Came over by barge, got it loaded, went through the little towns there and get into the launch site. I think they were saying that the truck was like over a football field long, getting this around all the streets and moving the power lines and things. So it was quite a chore. So you can see it there in our integration facility. Next slide. We've had some engine tests. We just had a recent one, I think it's been a couple weeks ago, about a 50 or 60 second test. So those are all going well. Next slide. A little bit about our launch facilities there at Wallops. And also is being built new in conjunction with NASA and the Mid-Atlantic Regional Spaceport there in Virginia. Next slide. Buildings are coming together. Horizontal integration facility, the pad, launch tower there's, they say the largest or tallest water tower in the East Coast or somewhere. So we're going to check and see if there's a Guinness World Record we can submit. Next slide. And this is kind of the graphic showing what it'll look like when it's all comes together later this year. Next slide. So where we are in Commercial Crew, we're part of the CCDev 2 proposal that's going on. The vehicle we propose is a wing vehicle. Again, we want to focus on the safety aspects, the reusability aspects, designed to carry 4 to 6 crew. It's based on the work we've done in the past with NASA on the orbital space plane. Orbital was involved with that with NASA back in 2000, 2003. So we're using that design to kind of, again, fit the needs of NASA transporting crew to the station. And I think that's all I have. All right. Thank you.
The first speaker who did not require the 2-minute notice. Very good. Good brownie points. All right. Another Jeff will now come up, Jeff Patton of United Launch Alliance. Here you go.
Well, thanks for having me here. Again, I'm Jeff Patton. I've got a lot of hats for this panel. I said I'm manager of commercial crew and cargo program within ULA, and that's just because I've kind of been enamored with that for many years and been working with a lot of the folks on the front row here and trying to make this happen. Who's ULA, or I guess I got to do my background. My background is I actually started working down here with Jeff many, many years ago for McDonnell Douglas over here in the A, B, and C and D buildings, and then joined General Dynamics soon after the Challenger accident, and been working Atlas 3 and Atlas 5 launch vehicle development, and once we got those vehicles flying, then went off and started to do advanced programs like Commercial Crew. So that's kind of how I got to where I am. So United Launch Alliance, who are we? We make Atlas and Deltas, Atlas 5 and Delta 4s. I'm a Atlas heritage guy, so I have a little deference to Atlas over Delta, but we love both our children the same. Maybe one a little bit more than the other, but in any case, there's a little video here. There's a little video here, kind of giving you background of what we do, and videos are better than me talking.
ULA combines the talent and expertise of employees from Lockheed Martin and Boeing to create the best launch vehicles in the world. Atlas and Delta vehicles have launched critical government and civilian payloads for decades, with an amazing track record of mission success. Now these two very successful teams are joining together to form United Launch Alliance.
Ignition of the main engine. And now ignition of the solid rocket motors. We have liftoff. Liftoff of a Delta II rocket carrying NROL-21 for the National Reconnaissance Office. This also marks the first mission for United Launch Alliance.
So that's one of the first videos we made under ULA to kind of give a background on who we are and where we came from and what we do. We do Atlas 5, Delta 4, and Delta 2s, and I'll talk a little bit about those on the next slide, I think. Atlas and Delta for crew launch. We have the capability with both our systems of vehicles, Atlas V and Delta IV, to launch all the crew spacecraft currently planned or in development. We work closely with everybody here on the front row to try to make that vision happen. You can see some of the vehicles we're working on. We can also do Orion. We're hopeful that we'll have the opportunity to launch it. We're working very closely with Lockheed to help make that happen. So we feel that with the demonstrated reliability that our launch vehicles bring to bear, that we can really get these vehicles launched as quickly as possible and to get folks back on orbit after the shuttle retires. So far, the EELV program, that's the Evolved Expendable Launch Vehicle program, that's the Atlas V and Delta IV launch vehicles perform under that contract. We've had 38 launches to date. All of those have been successful. 24 have been Atlas Vs and 14 are Delta IVs. And we're very proud of that history of mission success. We've also had 94 consecutive Atlas successes since 1994, and that's Atlas IIs, Atlas IIIs, and Atlas Vs. So we're very, very proud of that. But it's something we watch extremely closely, because in the launch business, you're only as good as your last success. And for those of us that have been through failures, it's not fun. And so we have a culture that is very focused on mission success. Next chart, please. This shows all the ELV launches. When you look at it in its total of all the 38, it's quite a few missions. There's a mix of all different vehicle configurations in there of Atlas Vs without solids, with solids. Same with on the Delta side. There are Delta IV Heavies in here as well. You can see these down here. And if you go to the next chart, you can focus in on our last heavy launch, the NROL-49, which was launched out of Vandenberg. It was the first launch for a Delta IV Heavy out of Vandenberg, and it was the largest launch vehicle that's ever launched out of Vandenberg. And if you saw the video, it was a very spectacular launch, and we're very pleased with that. Next chart, please. How are we going to fly people on our vehicles? For years we've kind of heard that you couldn't do it on ELV. We're really not quite sure how that came to be, because as we've been going down the path of offering crew launch, we feel pretty confident that our vehicles are reliable enough to offer a safe launch vehicle for crew. Our development history and heritage and demonstrated reliability is probably the key thing. One of the things we kind of tell everybody is the Air Force and NRO especially has never seen a reliability upgrade they didn't like. So our vehicles are about as reliable as they can be without actually degrading reliability by adding extra redundancy and things like that. So we're kind of at a point where you can add a whole bunch of money, get a whole bunch of additional systems on board, but it really ends up degrading reliability. So we really think that the fact that we have about the best reliability you can get now, demonstrated reliability in conjunction with that, because we're going to be flying these same vehicles, same Atlas Vs and Delta IVs that we fly today are going to be the same ones you fly for crew. So you get to prove out those systems on a non-crewed basis, and that really adds to your confidence and is really the right thing to do. We will also leverage the history we have with NASA certification. For example, our Atlas V, and this isn't the Atlas V hugging, but we are Category 3 certified in the NASA, or for the NASA Launch Services Program to launch the nation's most complicated and critical NASA spacecraft, like Pluto, for example. So we would use that same process and leverage that to ensure that we have human certification plus whatever other requirements that NASA will come up with. The design implementation, obviously, it's important to use flight-proven vehicles to go out and do that. That's why it's important here early on, as we're trying to get the crew launch capability going again, is using that flight-proven design. There's only two things that we would have to add to our systems to get them to launch crew. The first is the emergency detection system, which monitors the vehicle and tells you the health and status of the vehicle and when you're going to have a problem, and then tell the spacecraft it's time to go. We did that work, and I'll talk about that on the next chart, during CCDEV 1. We hope to continue that in CCDEV 2. And then right now we don't have a way to get people in and out at the pad. So those are kind of the two things, EDS and ingress and emergency egress are the two things that we really have to add to the system to make our vehicles human certified. Now, one of the things that we did during CCDEV 2 or CCDev1, was we did some testing at the NASTAR facility up in, it's outside of Philadelphia, I believe, where we gave them an ascent trajectory and the acceleration profiles, and then we had Jeff Ashby, who former astronaut, to actually get in there and experience those G levels and kind of see what he could do operationally to see whether he could really operate, because we do up in this simulation on an Atlas 5402. We do go up to about 4 Gs, so we kind of wanted to see whether he was still able to function with a typical Atlas V ascent trajectory. So you'll see in this video, you'll see him over on the right-hand side, my right, your left, to kind of show what he's experiencing. He'll have a little narration. In the upper right-hand side over here, you'll see the acceleration curve and kind of where he is on that. And then down here, you'll see a little animation of the events that are going on. So we just kind of wanted to see whether a human could actually handle the accelerations that we were seeing in a typical ascent. One thing you'll notice, our video folks kind of refer to this as the Blair Witch Project video, because it is in black and white, and if you'll notice, and I'm just telling you this ahead of time, you'll notice that his eyes are very white, and the NASTAR folks use that because their medical folks do some analysis based on eye movement and some other characteristics of the eye. So you'll see that they're highlighted, but so there's a reason for that. It's not just kind of a scary looking video. So. Go ahead. You should click on it.
It's considering it.
It's thinking.
Which is scary because
It shows the
At this point, I'm not having to pressure breathe at all. Pretty comfortable. So, in order to estimate the time, I'd say we're about a minute into launch, roughly. I don't know where we actually are. That's my guess.
Jeff, just so you know, you're at 1.7 GX.
Okay. Now, thinking about the abort controls, at this point in the profile, they can be just about anywhere. If I had a stick, my hand would be on that. That would be the best place. The second best place is probably under the hand. But so far, so good. And I'd estimate I'm somewhere around 2 minutes at this point. I don't know how close that is. You guys can judge. It's getting dark, so I'm having trouble reading my checklist.
You're at 2 GX.
Okay. Okay, I'm starting to feel my legs are starting to get heavy at this point. I'm feeling the blood coming out of them now. Beginning to tingle a little bit. I'm also feeling pressed very hard into the seat. Not very hard, but moderately hard.
2.5 GX.
I'm starting to feel the pressure of my throat now. Not uncomfortable, but firm. And I'm starting to feel my face push back. I'm going to try the reach drill again. I can reach not a whole lot different from 1.5 Gs.
3 GX.
Okay, but getting to the 5 on the G meter is much more difficult at this point. Okay, I'm feeling a lot of pressure now. Again, everything's fine, but it's getting harder and harder to talk at this point, as you can tell. Okay, my legs are feeling just about the same as they were before. They're beginning a little tired. You can tell I'm having a lot of trouble talking now to the cog drill. My peripheral vision is unchanged, and my visual acuity is noticeably dim, partly because of the dim lights, and partly because it's just hard to look down and see the rudder pedal adjust tab.
4 GX.
Okay, I'm able to start pressure breathing now. It's getting harder, and I can't really reference my checklist very easy at this point. In fact, I can't look down to see it. So, I'm pretty much concentrated at this point just on keeping my pressure breathing going. Whoa!
Staging. You're staging.
Okay.
second stage ignition.
Okay, and I'm feeling fine, by the way. I'm just describing the thing. Very easy. This is a good time. After there's going to be a recovery period of 10 or 15 seconds after that MECO, I think, until you can function again. But this is the time to function. I'm feeling pretty normal right now.
All right, it's kind of fun to watch that because, you know, obviously when the G levels went down, that was a little unexpected on his part. Next chart, please. And I'll go fast, Dennis. For CCDev1, we did the EDS prototype development where we did the hardware, software, developed the algorithms to go out and do some simulated abort testing. We looked at 4 different cases. 2 of them were things that happened pretty darn quick to make sure that our system could assess those and give the signal, and then a couple of slow situations like where you had leaks or you had systems that degraded slowly. And in all cases, the algorithms and the data we sent worked fine. So that was obviously something we're very proud of. Next chart, please. So what do we need some help with from JSC? You know, we haven't interfaced a whole lot with JSC the past couple of years, but we see that changing a whole lot because there's a lot of things that the JSC folks have that a lot of experience that we really want to tap into. The human system certification, safety and mission assurance from a human perspective, ascent trajectory design, human system integration, PRAs. Everybody loves PRAs. So that's something that we really need some help with, especially from a human standpoint. Next chart, please. So as a summary chart, we think our existing systems offer a pretty straightforward approach for a crew launch. Flight-proven systems, demonstrated reliability is key, especially here in the near term. We think there's minimal development effort for human spaceflight, and we have made significant progress on EDS during CCDev2, and we hope to expand that in the near future. That's all I have.
Thank you, Jeff. Again, keep some questions in mind. We have 2 more presentations. I appreciate your patience, and we'll have some time for Q&A afterward. So our next speaker is Brian Duffy of ATK.
Hey, what's up? The Liberty?
Yeah, the Liberty, the one-pager on the left there.
Did you just want the one? Oh.
Yeah. Hi, everybody. Pleasure to be able to join you. As was mentioned, my name is Brian Duffy, and been here at the Johnson Space Center on and off since 1985. Had the great pleasure of flying 4 space missions on the Space Shuttle, that incredible machine that you heard everyone talking about here, the thing that can carry 25 tons to orbit, bring 25 tons home, roars out of the atmosphere, dances on orbit, flies like a dream, and then roars back into the atmosphere and lands on a runway. Amazing vehicle. I retired out of the Air Force, left the astronaut office in 2001 and joined Lockheed Martin at the time, went down to the Kennedy Space Center and was down there for a few years. Because of my Air Force background from before that and my flight experience in space, they said, you know, you understand the military, you understand space, how about if you come up here and help us with this military space stuff that we've got going on in Colorado. So I lived in Colorado for about 5 years. And then they said, well, we looked around the corporation and got 140,000 people and only one of them's ever flown anything in space, so how would you like to go back to Houston and be the Altair program manager? And so I was going to do the same thing that Keith was doing, and of course we all know that story. So I retired from Lockheed Martin after nearly 10 years with them on January 31st, just recently, and on February 1st I started with ATK. So I'm learning how to spell ATK at this point. My first day on the job they said, oh, by the way, there's a SpaceUp Houston, it's a week from Saturday. We already RSVP'd that we're going to have a presenter and you're it. I said, well, that's nice, but what am I to present? And I said, well, that's your problem. You know, you can do that. Well, so very fortunate. I'm very fortunate that just earlier this week, they came out with a press release announcing some things that have been going on over the last year that I'm happy to be able to share with you here today. And the project or the plan is something called the Liberty Launch System. I'm only going to have one slide because it's that fresh. We don't have pictures of anything. But our plan is to take the solid rocket, the redesigned solid rocket motor from the shuttle, only instead of being a 4-segment, it'll be the 5-segment version that's been worked on in the Ares 1 program within Constellation. Use that as the first stage. Take the core stage from the Ariane 5, which is amazingly similar in dimensions and in performance to what was going to be planned in the Ares program, and it's pretty much just a drop-in system to be the second stage. And so we'll be taking essentially 2 mostly human-rated. Of course, the solid rocket boosters are human-rated. We fly people on them all the time, and we've flown 200, I think the number says 215 consecutive successful missions. And then we're going to take the core stage of the Ariane 5 that was originally designed to fly the Hermes. So they were designing that stage to be human-rated when the Hermes program was canceled, and then they stopped doing that. So there's a little bit of work left to do in human rating that, but it's clearly doable for us. So take those 2 essentially human ratable systems, put them together, and provide a safe transportation system to get crews to orbit. We can lift about 44,500 pounds, so we'll be able to lift any of the vehicles that are contemplated right now and being designed. The rocket, the launch system will actually kind of scratches a lot of itches, if you would. You know, the National Space Policy has said that we're going to have more international cooperation, and this is certainly one way to do that. We think that it'll help a lot in transitioning the workforce from the shuttle era to the next era in the commercial world. We're planning to use the VAB and the pads down at the Kennedy Space Center, so we'll be able to be able to leverage all of the money that's been invested over the years in the program. So we're very excited about it. Right now, as I said, it's just a 1 slide. The ink's still a little bit wet on it, but it has an awful lot of promise for being a great system for carrying any of the vehicles to the International Space Station. And the ISS is the focus for this. I look forward to your questions later. Thanks.
Not bad for just a few days on the job. Very impressed, very impressed. Okay, last but not least is SpaceX. Ken Bowersox is representing our other COTS partner, and take it away, Sox.
Yeah, well, I've lived here in the Clear Lake area since 1987. NASA assigned me to the Johnson Space Center in the astronaut office. Had the fortune to fly on 5 orbital missions, 4 of them based off of the space shuttle and 1 based off of the space station. My last assignment there was as the director of flight crew operations, where I was responsible for the astronaut office and all the flight operations at the Johnson Space Center. When I decided to retire from the Navy about 4 years ago, I thought, hey, it's time to look outside of NASA and see what else is available. So I stepped out from the government sector, and then spent a couple years kind of stepping back into the government sector as a consultant on review boards for the Constellation program until I joined SpaceX about 1.5 years ago. SpaceX is a growing company. When I first started with them, there were 650 employees. Now we've got over 1,200. We've got 3 major sites a large production and manufacturing facility. Well, it's large for us. It's about 550,000 square feet. They used to build 747 fuselage sections inside the plant. The Northrop company did. But Northrop left the plant. The plant was empty, and we took it over. We've also got a test site up in McGregor, Texas, where we test all of our engines and major structures for the Falcon 9 and Dragon and the Merlin engines. Plus, we do full integrated stage tests of the vehicles up there in McGregor. Roughly 150 people there, 1,000 in Hawthorne, and then another 100 or so at our main launch site in Cape Canaveral. We're also developing launch sites at Vandenberg Air Force Base. We have a small launch site out in Kwajalein, and we've got some liaison offices in Washington, D.C., Huntsville, Alabama, and we're planning to open one here in Houston. It's not going to have a lot of opportunities for people in the Houston area to work for SpaceX in Houston, but we'll probably have 4 to 10 slots there. Next slide. I like to show this in all my presentations just because people are sometimes amazed that we have a quality policy at SpaceX. Part of the reputation of the company is that we do things very quickly and aren't typically burdened by bureaucracy. But this is something we believe in. It's part of our ISO and AS 9100 certification. And it shows that we're interested in not just providing cheap vehicles, inexpensive vehicles, lowering the cost of access to space, all those things. What we want to do is provide the safest and most reliable and economical access to space. And the first part of that is the safe part. Next slide. This is how we do business. We could talk about this for a long time, so I won't get into all the pieces. But you've seen this approach a lot of other places. In fact, when I talk to folks who work in Apollo, they tell me this is what they did. Next slide. These are our 3 main products right now. The Falcon 1, our trainer rocket. It's got 1 Merlin engine on it, can carry roughly 800 pounds into low Earth orbit. It's launched 5 times. The first 3 times were partial successes. We got a little bit higher each launch. Trained our team, expanded our processes. The 4th launch, we made it into orbit. The 5th launch, we launched a paying customer, and their satellites up there working great right now, taking pictures of the Earth. The Falcon 9 is the follow-on to the Falcon 1. It's got 9 Merlin engines on the bottom and then a vacuum version of the Merlin engine on the second stage. It can carry roughly 20,000 kilograms into low Earth orbit. A little more, a little less, depending on what inclinations you go into. And then the Dragon should ride on top of a Falcon 9 to the space station pretty soon. It was designed to carry cargo to the International Space Station first, then hopefully someday cruise. Next slide. The Falcon 9 has flown twice. The first flight was last June with an inert upper stage, an inert Dragon on the top. The flight was very successful. At least it accomplished all of our major success criteria and hit its insertion parameters pretty closely. And then we launched again in December. Next slide. We've got quite a few customers manifested, both commercial satellite type launches and launches for the U.S. government. Of course, the CRS contract, the Commercial Resupply Services contract, is our biggest contract. It's about $1.6 billion for 12 launches, 20,000 kilograms to the International Space Station. Next slide. Planned development for the Falcon 9 is to upgrade the engines, make it a little bit bigger to carry more with the expanded single core vehicle, and then go to a triple core vehicle. Next slide. The Dragon spacecraft has a lot of potential missions, from carrying cargo to the space station to carrying crews someday, but there's also a really interesting mission called the Dragon Lab, where we would put payloads inside the vehicle, send them up for a couple years on orbit, and do microgravity science or other Earth observation or whatever type satellite science we wanted to do with satellites in the trunk. Next slide. This is an idea for what the Dragon looks like. The major components are the nose cap, the pressurized section, and the trunk on the back. The trunk is something that really expands the capability of the vehicle because you can put all kinds of great stuff there, just like the trunk of your car. And to make the vehicle more reusable, we have a donut-shaped service section just below the major part of the pressurized section, so we can bring back the tanks and maneuvering thrusters. Next slide. This gives you a feel for the dimensions of the vehicle. Typically, we're looking at 3,000 kilograms or so in the pressurized volume, possibly 25,000 or 2,500 kilograms down. But those are maximum numbers. We're really volume limited, so it would be less than that. We have to do roughly 1,700 kilograms of flight to meet the requirements for the CRS contract. Next slide. The big thing that we do that other vehicles don't do right now is return stuff to Earth from the space station. That's a unique capability of the Dragon. Next slide. The first demo mission for the Commercial Orbital Transportation Services Space Act Agreement happened first week in December last year. The start of the second week was December 8th, I believe, something like that, where we launched a simplified version of the Dragon to do 1.5 laps around the Earth, a little less than 2, but when it finally landed. Launched out of Florida, landed just off the west coast of California. The major objectives were to test out the heat shield, test out the orbital guidance, navigation, control, test out the thrusters in space, and all of that went very well. Parachutes opened just like they were supposed to, splashed down. We had a barge stationed not too far from the landing area. They pulled the spacecraft aboard, and this is what it looked like out there when we pulled it in. It looked like we could have just pumped up the tanks and flown it again if we had another Falcon 9 ready to go. Next slide. After we fly the C3 mission and go up to the station, get grabbed by the robot arm and berthed, all the follow-on CRS missions will be pretty much similar. They'll look like this. Next slide. And then if we get the capability to carry crew, which I think should happen reasonably soon, the missions would look like this, where we dock instead of using the robot arm to grab us and pull us into the station. Next slide. The Dragon, when it's modified to carry crew, should carry about 7. It'll be a little bit of a tight ride, kind of like coach seats heading across the Atlantic, but it should be a short trip. Next slide. SpaceX was founded to carry crew, so we've thought about it from day one. These are the 3 things that we need to do to Dragon to fit crew inside it. We need to develop a launch escape system or a launch abort system. We need to put in seats, displays, and life support systems for a crew. We think that would take us about 3 years from the time we get started. And a lot of people say, hey, that's very aggressive. How could you do that in 3 years? Well, it's important to remember that we've been doing this since the company was founded. So we've been thinking about crew. It was the reason the company started in the first place. So we've actually got an 8-year start. And if you add up 8 years and 3, that's really more like 11, which is a pretty reasonable number, I think. Next slide. Happy to take questions when the time comes.
Outstanding. I think what we're going to do is seat our panel facing the audience. We actually have some chairs. And we're going to take some questions. And how much time do we have left in the?
We can go to 9:15.
9:15. So we have like about 20 minutes. So I can't see anything because of the lights. But so raise your hand and yell if you have a question while we're getting situated. Thanks. Yeah, and you all get to sit. Good. Come on.
You get to be in the spotlight.
Yeah, don't be bashful. Okay, yeah, lady in the back. Do we need a mic for the questioners? Okay, just yell. Oh, okay, hold on. We are going to use mics. Sorry. Okay.
Okay.
All right, there you go.
This is for the folks who are working on crew vehicles coming down the line. The mic is not on. Okay, never mind. I was just wondering if you guys have kind of started thinking about what the division of responsibility will be for crew training and operations once you get started between you guys' company and NASA.
Who wants to take a stab at that? Crew training.
So you just want to know how we're planning to do crew training and operations? Okay, well, I'll answer first, and then I think Socks and others can go into it. Obviously, me having that background, that's one of the jobs that I've got. We're going to be drop testing the first vehicle to land on the runway next year, so I got to head into that pretty quick. So we're going to start with what we're going to do with the test pilots and how do you get them trained. You want to start with somebody that's good. So you'd start with test pilots. You wouldn't take somebody off the street. And so we're already working through that. A number of simulators that we will have on the ground. We're even discussing whether we'd want to have aircraft like the shuttle trainer aircraft to be used for that. So that's already in work. For the orbital missions, it'd be probably similar to what you're talking about, where we would have both training of crews and flight controllers. Probably going to do it a little bit differently than the way I was used to. I probably will take the guys that just did the design and development of the vehicle and then turn them into flight controllers, assuming I can make sure that they're able to make quick decisions fast. So already working along those lines. Mission control is going to be executed out of here, at least that's my goal. Working Space Act agreements to see if we can do that, assuming the price point makes sense. That's a lot of the issues that we're trying to work with on the government side, is whether we can not have to pay for the infrastructure cost of that kind of thing, and if they're already using it, for space station and for the Orion missions and those kind of things, then maybe we can just lease the space and be done there. But I can do it from other places as well. Did I answer your question?
I think a similar thing. I think the real question on crew training is whose crew are we flying, right? Is probably one of the questions, right? And so we have initially said our first test pilots may be Boeing, similar to what we've done on commercial airplane, but later, particularly for a NASA mission to ISS, obviously they'll all be NASA or maybe commercial crew going up. So our plan is to have our team train that crew, but they would be NASA crews. So for that, in that particular case, the commander would be a NASA person that we would train. As far as training the flight controllers, we're doing a very similar thing. Things we did back in the satellite days, we actually used our engineers, our development engineers, as mission controllers because it's typically a short mission, and so you don't have them as all the time like you had on a shuttle or station mission. So that's our plan today. Of course, we will be flexible depending on what our customers want. So a lot of it depends on what our customers ask for.
Yeah, and that's the real answer, is what the customers want is what we'll probably provide. But I can tell you that it can be done very inexpensively. And if you want to look at a low-cost model for training crews, look at what the Russians do. It's incredibly lean what they get away with.
And from an orbital perspective, we're kind of in line with what's been said before. We have a capability we have from our own satellite operations control we do in Dulles, but we're going to look for a partnership with NASA here locally to do that kind of work for a crewed mission.
Where's the mic go? Yeah, for right here.
Okay. I want to thank you all for being here. I hope this is the beginning of many discussions that we have with the commercial industry and all the expertise we have here, especially when we think about crewed missions in commercial space. So I hope that we'll have many opportunities to speak with you all and get the best use of all these new and exciting capabilities with all the expertise that we've shown here at Johnson Space Center over time. As far as impediments, I mean, beyond the obvious economic ones, there will be organizations that are going to try to help ensure that these things can come together. If you could think of one or two main impediments, I mean, at the national level, at the state level, for your companies to operate in this commercial environment, what would they be? There's third-party liability issues, FAA promulgating regulations. There's a whole raft of bumps that have been put in your way. What are the ones still remaining? How can we help you smooth out the ones that are still there?
Of course, there are a lot of impediments, and you mentioned the first one. The first one is the business case. We're all companies, and companies have to make a profit or they won't survive. So it has to be a business case that will close, and the biggest uncertainty in the business case Not only is it NASA and where they're headed, but it's also the commercial market, and will it expand or not? The companies have made bets on that before and lost those bets, but I think things are changing very rapidly, and I think one of the things that the administrator just said a couple days ago, that he is essentially ceding to the low Earth orbit market to commercial companies is a big deal. And so if that's where NASA and the government are headed, I think that really helps the companies go forward and makes commitments to do business in low Earth orbit.
Yeah, Keith did a good job of, I think probably that's the primary one. And me being an old NASA guy, a lot of us are old NASA guys, probably the hardest one, former, I'm old too, but is how invasive the oversight and insight type models will end up being when we get done. And I know there's a lot of discussions going on at higher levels on how we can do that, because to close the business case, you got to make sure that you allow the company, especially fixed price contracts, because I think a number of us, I might not have said it, but fixed price contracts is a big deal. So if you're committing that you're going to do something on a particular date and time, then you've got to be given some latitude to figure out how to make schedule. And sometimes when that makes schedule doesn't mean it's not going to be safe. You can do stuff, and there's a lot, using Jeff Patton's analogy, we launch a lot of payloads on top of that rocket. So, those kind of things have to be worked through, and I'm talking about human rating and those kind of things. That we're still, it's a give and take, and I think that's one of those that we'll have to, come to agreement on.
And I'll just kind of piggyback on that, and the contracting method is could be a real impediment for us. A fixed price development contract is something that's pretty hard to sell to a board of directors out there, and there's a significant amount of risk that you have to be able to deal with. So I would put that way up near the top of my list for impediments.
For me, when I look at the things that could stop what's going on in the commercial world, it's the thought that we're competing with established programs. A lot of people a year or so ago, when Constellation was under threat, started throwing a lot of rocks at the commercial programs, trying to make them look impossible as a way to keep Constellation going. And people forgot that when the vision for space exploration came out, it had two parts. One part was what became Constellation. The other part was to encourage commercial. But that sort of got forgotten, and the attack happened, and the commercial guys were attacking Constellation, and the Constellation guys were attacking commercial, and we were so busy fighting each other, we really came close to losing our space program altogether. And I don't think the threat's gone, and I think probably what's most important now is figuring out how we work together to take the best of all the different possibilities that are out there to start focusing on what we're going to do with them and moving out to explore.
From a ULA perspective and a Jeff Patton perspective, we need people to make decisions and to move out. We're spending too much time, and kind of what Ken's saying, we're spending too much time churning, and we need people to make decisions and start moving out, because we're wasting time. We're all getting older. We're all getting older and nothing's happening. That's what none of us want. We want to move out. There's plenty of stuff out there. Commercial crew can go to LEO and ISS. Fabulous. Let's get going. We can get Orion going to EXO LEO. Get it going fast. We got to get people making decisions to move out. It's killing us. It's killing our business because of the indecision. We can't forecast what's going to happen in a year or 2 or 3 to be able to make sound business decisions. We need somebody to make decisions, even if they don't fall in our favor for whatever reason. It helps us make decisions on what we're going to do going forward. But make some decisions and let's get on with it.
Yeah, I have to ditto everything that's been said here. Of course, business cases are our primary concern. This is a long-term investment. It's an expensive investment. There has to be a long-term look at this to make it worthwhile. There are some hurdles with FAA or third-party liability that have to be addressed along the way, but really it's looking at the long term. dealing with NASA has been working fine with us so far in the COTS world. As we move into commercial crew, there's going to be a little bit more of a relationship that has to be worked out there between insight, oversight, requirements. There's a lot of NASA requirements out there that need to be better organized so we know what we're designing to make a efficient, safe vehicle to make them happy.
We have some questions from online. From San Diego.
Hey guys, question is from the internet. Vax wanted to know, sorry, give me a second to scroll back up for that one. Former shuttle program manager Wayne Hale and others have described blackout phases during ascent for crew on EELVs. How's this being addressed?
Yeah, I'm kind of familiar with that. There are none as far as we can tell. That's been one of those urban myths. I refer to it as an urban myth that's been around for years. For any of our vehicles, we can't seem to find any. So I don't know where it came from. Well, I shouldn't say that. We kind of understand what the genesis was, but we could never recreate it based on our data. So and that's across our whole fleet. So there are none that we're aware of. And the performance impact for designing, for shaping the trajectory to close black zones is very minimal. So I'll just kind of leave it at that. Just recently, we have started working with the NASA JSC folks to understand what trajectory constraints they were using for the Orion program to make sure that the basis of that statement is true. And fortunately, based on our technical interchange, we've been designing to the same parameters. There really isn't any difference. So we feel very confident that we can shape our trajectories to eliminate black zones and not have a big performance impact.
And just real quick, just to reiterate what Jeff just said, for the Dream Chaser specifically, we had looked, during CCDev 1 at the Atlas V and the Dream Chaser, and there are no black zones. We have cross-range capability to get on a runway no matter where the abort does occur through that trajectory, and got a lot of data to back that up. So what Jeff just said, I know works for our spacecraft. We've got a lot of capability there.
A black zone is really a combination of the capability of the spacecraft on top of the launch vehicle and the launch vehicle. And all of the providers here are working to make sure there are no black zones in their design. So basically my understanding of black zone is a case where you cannot safely abort. And I think everybody's working to make sure that's not the case. And it's one of the basic fundamental design constraints that we're using. So there will be no black zones.
There was another question from Jepif. He wanted to know, in regards to Liberty, is that going to be a 4-segment solid rocket booster or a 5-segment solid rocket booster?
Yeah, it's going to be the 5-segment solid there. Yeah, it's going to look a lot like the Ares 1X tested. It's going to be a little bit, just slightly different in dimensions, but a lot of the flight test data that we got from Ares 1X will be directly applicable and usable for the Liberty programs.
All right, Internet will hand it back. Internet out.
Internet, how about San Diego? Do they have questions?
Actually, I have a question.
Okay, go.
So, the gentleman from ATK, you guys released your press release just so you could present here at SpaceUp. Is that not true?
It shows us how powerful you are.
I didn't know.
That's where Cindy wanted you to go, I think. Yeah.
Does anybody else have questions?
Yeah, actually, the moderator's going to interject one.
Ooh, the moderator has.
We're here in Texas, and in fact, Wayne, I was expecting you to ask this question, but what is the impact? There's a lot of concern about jobs, through government contracting or the commercial approach. What comments can you state in general about jobs doing things commercially and in Texas? Because Wayne's involved in the Texas Space Alliance, and there's a lot of interest in jobs in Texas. Any comments on the commercial approach?
Well, I'll have the mic and then I'll pass it on. Liberty would probably not have an increase in jobs in Texas. However, it would protect up to 200 jobs down in Florida, and then ultimately add another 100 is what we're projecting on down there. So it would be 300 jobs, but they'd be down at the Cape where we plan to launch from. So.
I guess I'd have to say right now our team is probably 30% space shuttle folks. So when space shuttle is shut down, a significant number of our team will be folks, for the most part, that are current Boeing employees working space shuttle will be working CST-100. So as far as most of that design will be done here, is where we plan to build it. We're still looking at various options, but definitely a lot of jobs here in Houston.
Yeah, and I'll speak it in two different ways. In terms of we're hiring right now, obviously, because we're staffing up for the full program, and a lot of the skills that Keith just talked about from the shuttle program. You know, we have been looking. You know, it's a winged vehicle. It has basically the same characteristics. You know, the same thermal protection system, the same kind of processing. We are looking to the Kennedy Space Center stuff. All the flight dynamics are very similar. So we are already looking at the skill basis for that kind of thing. It's in two phases, though. We are going to be building the vehicle in Colorado, and then we're going to be doing the execution out of here. I mentioned earlier about the leveraging of stuff that we are doing with the Johnson Space Center as well. For example, the GNC work that we were talking about, there's a number of other facilities and capabilities that are done here. And the cool thing about these Space Direct agreements, they're in reverse, where basically you can buy a service. I know Keith already did that through the last program. I think he was showing you the ArcJet work that they did out of Johnson. We're doing the same thing. So that kind of work is going on as well. And we want it to continue. So this is a new relationship here with signing of these umbrella agreements that allow you to do tasks for here. We will, you know, like I said, I'm starting a Houston office, but it's going to start small for now, and then as we get moving towards where JSC is good at, like the execution phase, then we'll have more folks here.
You know, when it comes to jobs, the problem we have right now is not money. If you look at it, the amount of money that's going to be in human spaceflight is about the same. The problem is we don't have contract mechanisms to keep people working. And the key to having contracts in place is to make decisions on how we're going to move forward so that those contracts can get laid out and people can be put back to work. Now, some of the jobs will probably move, and there may be some folks that need to move away from Houston or away from the Cape to different parts of the country. That is the way it works in the defense industry and has for a long time. You can ask some of the people here who've had moves like that in their lives. But the fact is there's going to be a need for the type of people that are here in Houston in the human spaceflight program in the future, and the key is to make some decisions and move forward.
And this is one of the things being on the end of the aisle. We're kind of just reiterating, yeah, ditto for everything they said. I mean, ULA is looking to expand our presence down here, but a lot of it depends on what the future holds, and that gets back to my previous comment about making some decisions. But we recognize that there's a lot of expertise here in the area that we want to tap into to help improve our vehicles for human spaceflight. So what's that mean in the future? I'm really not quite sure, but we certainly see a need there.
And from orbital, with our winged vehicle, we're similar to what John has mentioned, looking at the resources and the critical skills that are here at JSC to draw upon that in support of developing that vehicle. You know, draw upon JSC and the NASA folks and their NASA contractors to help us make that vehicle happen.
I think we have time for one or two more. Marianne? Over here.
Hi, I'm Marianne Dyson with National Space Society. We're going to be doing a blitz on Capitol Hill in about 2 weeks. And what message would you like us to take to our members of Congress that would help you? I assume you want them to make some decisions. So what would you like us to say to them? We're talking about Congress now, not the administration.
That's a scary one. You've got to be careful what you say, right?
Yeah.
Well, I think we endorse what the administrator said on, I think it was Wednesday, at the FAA Council, that NASA should work to leverage commercial capabilities for LEO so that they can save some money, quite frankly, so that NASA can then go do those hard things on exploration. So I think that's a very good mix. and it'll allow the opportunity for commercial space. And at the same time, NASA can go back to doing what they're good at.
No takers.
You want to tell Congress anything?
This is your big chance, guys. Come on. All right, go Sox.
Well, I mean, what would really help is an appropriations bill. You know? I mean, that's what we need. I mean, we can't move out with Commercial Crew until there's enough money there to do the job, and that's what we're all waiting for.
Yeah, I again agree with all of this. You know, I think it's important. If I just sort of focus in on Commercial Crew, I think it's important for everybody to understand that NASA's at a key point where they can make some decisions on how to structure that program, the way they do the acquisition approach, the way they fund that, the milestones they give everybody to meet, and the requirements they levy on everybody up here to provide that service is really critical now, because NASA can decide to make that a very cumbersome and burdensome program such that it'll never be commercially viable, which is, I think, something everybody here wants. We want to see more flights to LEO, and NASA really has to decide what they want that program to look like, because we don't want to get 3 years down the road, 2 years down the road, and find out, geez, we have an unexecutable program, because that's not good for any of us, especially if we're investing our own company money in this. So NASA needs to, and Congress for that matter, needs to recognize that they got to give NASA the flexibility to develop and implement a program that's commercially viable. You know, we've been working with Bigelow for years as well, and we really want to see him be successful. But NASA can help enable these other adjacent markets by the actions they take here in the near term. So that's something maybe that's a Jeff Patton perspective that we would like to see NASA and Congress decide is let's make commercial viable.
Good comment, Jeff. I think we have time for one more question.
Thank you. And gentlemen, thank you for coming out to do this. I'm actually a member of Joe Smo Public. I do not work for NASA. And I know how chat rooms work, and I know how SpaceUps work, and I'm going to be bold and ask you guys this, because I know everyone in here has questions, especially me. And I know we want to continue this discussion. And with the wiki page on SpaceUp and everything, would you guys be willing to take questions, whether via email, if someone gets your contact information, so these people can continue asking you the questions they want, and I can continue asking you the questions they want, because A, it's going to be outreach for you, and B, it's going to give us the information we want from you with time to formulate answers instead of being on the spot. So would you guys be willing to do something like that if someone started setting it up?
Absolutely.
Would you guys in here like it if they did something like that for you guys? Yeah. Okay.
It was short and sweet. Yes, very good. Anyway, I want to thank you all for coming. A great panel, and particularly on a Saturday night. So, and the audience too. Again, thanks very much, and turn it over to Jim.
All right, thank you. Yeah. I don't know how many of you have ever witnessed this sort of thing before, but this is actually kind of historic to see this many competitors together agreeing on the same agenda, which is really, we need to move forward with human spaceflight and stop fooling around. So I appreciate the fact that you all brought that message here.
I have to defend the program of record. I will.
There you go. Somebody take the picture real fast. So, before we go out for the star party, Cindy had a few words that she wanted to say to the panel as well, and so thank you all, and here's Cindy.
We're running out of hands.
You're running out of hands?
Would you be my... Yeah, thank you. Okay, you're my mic man. Wow. This is what you get here. So I want to share the power of social media with you gentlemen. And where's a woman? Excuse me, just want to point that out. Okay, so... oh, of course. How did I forget that? So somebody tweeted this earlier, and they said, Houston, you know this commercial panel? Awesome info. The problem is I'm just now hearing about it. Please be proud and talk more publicly about it to the general public. So this person may or may not be in the room. I will not disclose that information. So that's just letting you know that, yes, you're just starting, well, in the last couple of months you've started going out to different conferences and sharing the information, but it doesn't get out to the public from just the conferences. So we're glad to have you here, and I appreciate you being here. Also with videos. We tweeted that ULA Launch was here, and someone said that ulalaunch.com has awesome launch videos to share. So little competition there for the others. And also, another tweet was just an awesome commercial space panel here tonight, and we thank you all for taking the time to come out. I would like to thank you with Cakey Pops, which are cake balls on a stick. Very original. These were donated. There is a woman who's starting her own business. It's Delectable Pies, and we have them for everybody. So.
Flip it around. It's this way, and it's a dragon.
Terrific. So before I hand these to you, I'm going to let everybody know Craft Lass is going to play in here music until 10 o'clock. The telescopes are set up outside. It's clear skies, so enjoy the telescopes. And I believe our panel members are going to be around for networking in the lobby. If you guys would like to ask them any questions, network with each other, and we'll see you. I will kick you out at 10 because I want to go home and go to sleep. And we'll see you back here tomorrow morning at 9 a.m. Okay.
Fantastic. Thank you, everybody.
I'm going to concentrate on the CCDev1 progress, and then I'll briefly touch on the other two things. I think I've got 10 minutes, so I need to go fast. Next chart. A lot of people don't know much about Sierra Nevada. I didn't know much about Sierra Nevada when I first started. It is not the beer company, although I wish it probably was. Always say that, and I get that. I get asked that question all the time, so I keep telling Mark we just need to buy them so that we can actually have the beer keg with us. Sierra Nevada, actually, as a company, has been around for a long time. And I'm not going to spend a lot of time on this, but they did a lot of work. They still do very good work in defense side of things. And so there's 7 groups here that you see on these charts that have been around. The 6 to the left have been around for a long period of time. The one on the right is the one I'm going to concentrate on, which is the Space Systems Group. That was formed in 2008. And so the company was doing so well that they wanted to venture out a little bit more into the space sector. And so, but there's a lot of good work over here on this company that's been around for a very long time. I'd spend more time on it if we had more time, but so on the Space Systems Group part, in 2008, Sierra Nevada acquired 3 different companies: Microsat Systems, StarSys, and then SpaceDev, which y'all have heard something about from the previous time. And so that now comprises Sierra Nevada Corporation. So it's a pretty big company, over $1.2 billion in orders last year. So not a small company, been doing this for a long time. Have components and parts and pieces on over 300 space missions, and some of the stuff is shown on here. Next chart. So on Space Systems Group, again, we've got basically 4 product lines. Spacecraft systems type stuff, which is shown up here, including things like the Orbcomm Gen 2 satellite, which is a more of an assembly line type contract where they've building a number of satellites to put into space. And I think SpaceX is launching one of those on a Falcon 9 here soon. And so that's a multi-satellite service that actually like tracking packages and those kind of things, what those satellites do. Subsystems and components, there's a lot of components that we have put together. Very proud of that record that they've been doing, and that's in Louisville area where I commute to every single week. All of these things are with this one. Space Exploration Systems is the area I work on. I'll concentrate on Dream Chaser here in a minute. And then on the prop systems, most of you guys probably are aware or have heard, if you're sitting here listening about commercial space, Burt Rutan was able to successfully do the Spaceship One flight, and that was the motor that was used to get Spaceship One up was built by SpaceDev, which is now Sierra Nevada. So next chart. So this is just the chart summarizing all the capabilities and that we've done. The 4,000 components. Mark Sarangelo, when he briefs us, always very proud of the fact that we've had over 4,000 components on 300 space missions, and not a one of them has broken yet. For example, Spirit and Opportunity that are on the surface of the moon, all the moving parts on those things are there. Next chart. So on the space system's locations, this is where some of the parts are built, like the environmental control and life support part. I mentioned Orion earlier, for example. Some of the parts that Hamilton, they're sub to Hamilton, it comes out of that area there. The Poway, California plant is where the rocket motors are built, and then the test facility for the rocket motors is also in California, not that far off. And then Houston, we're just now starting to set up. I am the guy that's going to be starting to set up the Houston office of that. And the main focus of where we're doing all of the component work and actually going to be putting the Dream Chaser together, including the one that we're working on now, is out of Louisville, Colorado, which is just south of Boulder. If you guys never, beautiful place when it's not minus 20. So this is a picture of the Dream Chaser. It's a winged vehicle that. So now I'm going to focus specifically on the space exploration systems. It's a winged vehicle. This is shown docking to Node 2 forward, which is one of the two ports that NASA's been working on us for. I'm working on the integrated system thing. That's why Jim handed this job to me, to make sure that that'll work. Got a lot of experience with space station. The scale, if you compare this to the space shuttle, distance from nose to tail is about 30 feet, and from tip to tip on the airfoil wings, it's about 27 feet, just to give you an idea of the size. 7 people inside the cabin, two pilots, and then 5 passengers. Next chart. A lot of people don't realize that the shape that I was just showing you flew in orbit. The Russians did it on a spiral, what they called the spiral program back in the late 70s and early 80s, what they called the Bor 4. Sox may remember. I don't remember what the acronym is, what BOR stands for, but it's some Russian acronym that basically means being able to do these orbital missions and reentry. And they did that all prior to the Iran program, got a lot of TPS knowledge on the fact that that system would work. And the picture's not shown here, but an Australian P3 apparently saw the thing being pulled out of the water. They took the sky photos, sent it up to Langley or wherever, and then somebody asked Langley, CIA or whoever, to reverse engineer the thing, and that turned into what we call the HL-20. So the HL-20 has got over 2,000 wind tunnels, 2,000 wind tunnel tests that were performed during that period of time. And for a brief period of time, if you look at history, the HL-20 was going to be the next generation manned spacecraft. And then things changed a little bit, and Dan Golden came in, and things got overcome by events, and we ended up with the X-38 that was managed out of JSC. But it was nothing to do with the design. It had to do with just what NASA thought was the that they wanted to go with, and so we went out of the JSC design. Chart. So that's the Dream Chaser heritage. It's got a lot of good heritage from the NASA HL-20.
Is a commercial crew development program. We're just finishing up right now with a $50 million investment in activities of 5 companies along those lines, and proposals are in for CC Dev 2 right now, next step. And we'll see what the budget says next week about the full commercial crew program, but last year the president had proposed a nearly $6 billion commercial crew program. So we're really excited about this new exciting program to really develop commercialization of low Earth orbit and help free NASA up to go back and do the Lewis and Clark stuff that we do so well. And we have a great panel of 6 companies here today. Rather than read your bios, which I don't even have, I'm going to let you introduce yourselves as you begin. So we're going to start with John Curry of Sierra Nevada.
Can everybody hear me on this? Okay. So I'll let you do the charts. We'll start with the charts. I think most of you here at the Johnson Space Center in the Clear Lake area might know me, but my name's John Curry. I worked at JSC right down the street here for the last 23 years, first as a flight controller, and then I was a flight director for about 10 years on the shuttle and the space station. And then my last shuttle flight was STS-116, a 12-1 mission. That ended in December of 2006, and then in January of 2007, Jeff Hanley gave me a call and asked me to go work on Orion, which I did work on the Orion project as a vehicle integration manager. I've got a lot of blood, sweat, and tears on that space vehicle, so I look forward to eventually seeing it fly, and I want to make sure that that's one of the things that you get is that you know, space flight is important no matter what particular vehicle you're talking about, and that's a good vehicle. I spent a lot of time on it. So I did that from 2007 until 2009, and then got promotion up to Constellation Design Integration Manager, and that was going really well up until February 1st, and then things changed a little bit. You guys are laughing, so you know what happened after that. And so after that point, after working on that for another few months, I went ahead and took a job with Jim Voss and Mark Sarangelo, and working on Sierra Nevada Corporation. So that's what I'm going to talk to you about, is what we have been doing at Sierra Nevada with respect to commercial space and the space vehicle that we have. So next chart. Let's see, these are just the questions I think that Cindy asked us to say something about, so hopefully I'll cover these at some level where it says the progress made over the past year. We didn't do anything with COTS. That was, like he said, that was Orbital and SpaceX.
It's just very low. All right. So here's the second half of the evening. That was a fantastic visit from Clay. I appreciate the fact that he came over. I hope you do too. But we're going to take a shift now to the era of commercial. And I think this is going to be a fascinating session. It's going to be chaired by Dennis Stone, who is the Assistant Manager for Commercial Space Development in NASA's Commercial Crew and Cargo Program at JSC. He has been the chair of the business committee for both of the COTS competitions, and that stands for Commercial Orbital Transportation Services. I always mess that up. I want to say off the shelf. Commercial Orbital Transportation Services. Yeah. He spent 20 years in NASA working on the space station program in a variety of positions, including Chief Systems Engineer of the Assured Crew Return Vehicle, Manager of the Avionics Integration, and Co-Chair of the ISS Commercialization Working Group. Prior to working for NASA, he's worked for McDonnell Douglas, Ford Aerospace, and Rockwell. He has a bachelor's degree in physics and in electrical engineering from the University of Hawaii, an associate fellow of the AIAA, and advocate of the Space Frontier Foundation. Please welcome Dennis Stone.
Thank you, Jim, and thanks everybody for coming out on the weekend to show your support for space. And tonight, your interest in commercial space. This is something that I've been interested in for a long time, shall we say, and I'm so proud and honored to be part of really a new and exciting effort by NASA to stimulate the commercial space sector. And we're doing this in several ways. We started about 5 years ago with COTS and Commercial Orbital Transportation Services. And this is the two-phase program. The first phase, NASA is an investor. We had $500 million, and we were invested in two companies, SpaceX and Orbital Sciences, that are developing the ability to fly cargo to, and in some cases back from the space station. And this first phase is one of development and demonstration. The second phase is a contract from the ISS program, the Commercial Resupply Services Contract, or CRS, and that's a multi-billion-dollar contract. So we're putting our money where our mouth is, and we're really trying to get the commercial space sector routinely carrying cargo to and from low Earth orbit. We're also beginning to make small steps toward the next logical step, which is to allow commercial industry to carry people, beginning with our astronauts up and down to low Earth orbit. CCDev
mentioned that it's 7 crew capable. One of the things, just like Keith and I were talking 2 minutes, so I need to go faster. This is the capability of the vehicle. It launches on top of an Atlas V. Jeff will talk about that. So next chart. We've been working on this for quite a while. Next chart. So the accomplishments, hey, 2 minutes, I can make it happen. So these are the 4 milestones that we did during CCDev 1. There's a lot of good stuff. It's very hardware production centric. I like that. It's one of the things I like this. You know, you can show tangible progress when people, you cannot dispute hardware. So that's what we did. We built the tools to make this, and so this is turning in what we call the engineering test article, and that is going to be the vehicle that we're planning to drop from 45,000 feet next year. So, and go back one more real quick. We also did a what we were talking about, what we call the hybrid motors that are used on the back of the Dream Chaser. That's a rubber, green propellant, rubber and nitrous oxide is the way that's done, just like on Spaceship One. What we did different from what Spaceship One does, we had to prove that it works in a vacuum, because Spaceship One was doing it in the air. We did multi-start capability to show that you could do it for rendezvous and deorbit. Next chart. This is the other stuff that we did, a lot of GNC work. Next chart. A lot of other work. I'm not giving it due credit on what we were able to accomplish. Next chart. And then I think if I've got 1 minute, the last thing I'd like to show is we partnered with the University of Colorado Boulder. Some grad students did built a 1/6 scale model of this thing, and can we cue up the video? And it's less than a minute. But University of Colorado Boulder did this with us. You know, the students built this vehicle. Sorry for the noise. So this is showing, I don't know if you can hear me, but this is what the students doing the work on this.
A scale model of the Dream Chaser was created. The model was subjected to both functional and flight tests.
5 seconds.
So this was December 9th.
Good drop, good drop. Confirm release. Ground station confirmed vehicle is flying.
And this, remember, there's nothing wrong with the design of the vehicle that's causing an oscillation. It's just because of the way
Vehicle
that
with
the vehicle
128
is
knots
built.
performing nominally.
It's not that.
Ground station confirmed chute deployment. Can I have a visual? You got a good shoot. Copy, good shoot. And ground station confirms touchdown. Thank you.